The process of starting up in FPG revolves around a 4-step process. There's a document that is an addendum to the manual, starting the piston cylinder. Each step gives a definitive go, no-go criteria as far as if it's acceptable to go on to the next step. To begin, it says verify the FPG balance stability. Looking at the screen, we have to look at the counts value, and we are looking for count stability. The criteria is plus or minus 10 counts. So with the piston cylinder removed and the gimbal ring steady, we're verifying that the end value is not moving around by more than plus 10 or minus 10. And as we can see, we're very stable. We're stable to within about 1/10 of a count. Once we have balance stability, then we can go on to step 2. Step 2 is installing the piston and aligning. We take the piston cylinder, pinch and grab, and I'm going to take my hand and pat it with a paper towel to keep my fingers from touching the critical surface of the piston. Before we install, you have to ensure that the upper O-ring is on top of the cylinder. And when I install, I'm looking for the indexing slot on the cylinder through where the indexing pin is to be placed. It's a 3mm Allen head. Turn it till it's snug but not tight and the surface is flush. Secondly, take a piston retaining nut. Get a visual alignment of the slot on the piston. You have to be very careful with the piston retaining nut. It's made out of stainless steel, yet the gimbal ring that it threads into is aluminum. If you feel any hesitation or binding, you have to stop your forward motion and back it out until it frees up. If you force it, you can strip the threads out of the gimbal ring. So again, get a visual alignment, insert the pin or the nut, and it's in. Now that the piston is installed, it becomes the critical task of aligning the piston within the cylinder. From the manual, we have an excerpt of 4 methods that are used to align the piston with the cylinder. Method 1, Method 2, 3, and 4. The methods that seem to work the best is a combination of Method 2 and Method 4, where Method 2 is considered a coarse adjustment and Method 4 more of a fine-tuning. We start with the coarse adjustment. That's method number 2, where I grab onto the piston retaining nuts and I lift up and I let it drop. I do this 2 or 3 times. Once we finish method 2, move immediately into method 4, which is the fine adjustment, and that is the light strumming. I take my finger and I lightly strum across the front of the bearing. And when I strum, I'll look at our end value. And what I'm assessing is where is our home position. If the piston is aligned, it'll come somewhere minus 200, minus 175. Really depends on your piston and air density. So it looks like minus 188 is our home position. So I'm going to employ what we call the power of 3. And the power of 3 simply states that if you can make something repeat 3 times, chances are good that you haven't caught a transient condition. So we do the method 4 strum 3 times, each time evaluating the results to see, does our balance come back to the home position, and is it stable to within plus or minus 10 counts. So going back to the piston, I lightly strum it, and then I look at our balance output. Does it come back to its home position? And generally, within about 15 seconds, it'll be there. So we started at about 188, and we're about 189. Again, plus or minus 10 counts is what we're looking for. So that looks pretty good. So I'm going to repeat it a second time, see if we can get the same results. We look at the balance. Does it come back to home position? right about 189. That's great. And we'll do it a third time and aim for the same results. And it comes back to 189. So that is a good sign. That tells us that now our piston is aligned relative to the cylinder, and we can move on to step 3. Step 3 involves putting on the O-ring and the lower mounting post. The O-ring is what seals the lower mounting post to the upper. The inside diameter of the O-ring is a little bit larger than the diameter of the shoulder which it fits around. We sometimes jokingly refer to this as the magic O-ring. And one technique that might help you get the O-ring to stay in place is to make it a little bit tacky. And the poor man's way of doing that is simply to cup it in your hands and breathe on it. Just put a little bit of tack on it. And we gently place this around the gimbal ring. And the trick is to place it flat without rolling it. This might take a little bit of work on your end. Okay, now with the O-ring up, and it's not really up. We've got to make sure it's up and not kind of hanging down. We don't want to roll it and pinch it, which is the reason we put the O-ring up here instead of inside the lip of the lower mounting post. Putting it up here first does not always succeed. But the risk is if we put it in the lower mounting post, we can roll the O-ring, pinch it, and break the seal. With the O-ring attached, we now take the lower mounting post and do a visual check. Make sure that the bottom O-ring carrier is installed. It's the brown Viton material. And what's important about the O-ring is that it's present and installed in the proper orientation. There's a metal lip on the bottom of the carrier. That metal lip must face down and away from the piston cylinder assembly. When you put the lower mounting post on, align it, rotate it slightly to find the indexing pin, and then taking the knurled ring, keep it flat, and engage the threads to screw it on. Every time I touch the mounting post, I am introducing a potential shift in the piston alignment, and so therefore we have to check the output of the FPG. Are we back at our home position? Yes or no, plus or minus 10 counts. And if we are, then we quickly go and turn on the lubrication gas. When we turn on the lubrication gas, if the piston remains aligned, the balance output will follow a very well-defined profile. You can see that it's increasing by a rate of about 10 counts per second. The balance output will go positive to about 25, maybe 50 counts, and then slowly start to come back down towards 0. If the alignment is good, this profile will happen. What can happen sometimes is if there's a misalignment, or worse yet, some contamination on the piston, when we turn on the lubrication gas, the balance output will shift by several thousand counts. If this happens, we refer to the piston as being toppled, meaning it's no longer perfectly aligned with the cylinder, and it will need to be either cleaned, or you simply go back to our procedure and go back to step 2 and realign the piston with the cylinder. With this 4-step process, if one step does not pass, go back to the previous step, make sure that you can get that to pass, and then proceed forward. Now looking at our balance output, we can see that our end value is slowly coming back down towards 0. And a technique to look for is, does the end value come down gradually and evenly, or does it bounce around? If it bounces around, that suggests that we might have a slightly dirty piston. In this situation, we can see that it is gradually and evenly getting smaller over time, and that is a good sign. So to review, once we put the piston in and we get it aligned, and we turn on the lubrication gas, it will follow, it being the balance output, will follow a very well-defined profile where the end values will go positive at about a rate of 10 counts per second. We'll reach a peak of about maybe 25 to 50 counts, and then slowly asymptote back down towards 0. From this point forward, our end value will take about 15, maybe 30 minutes to become stable. If you look back at our FPG mounting post, you'll notice that we don't have the valve 10 manifold on, and we have open ports on the top, bottom, and on the bottom where the vacuum connects. This means that our piston cylinder is somewhat open to the influences of the lab. So if there are air currents moving or temperature changes, it's somewhat influenced, and we can make it a little bit more stable by attaching the valve 10 manifold. So I'm going to attach the valve 10 manifold and just essentially isolate our piston cylinder from the environment. And that will allow us to see how stable it really is. When putting on the KF16 flange clamps or the KF25, it's not necessary to get them super tight. You want to get them snug. The O-ring carrier will ensure that you get the proper clearance, and the O-ring will do the seal. So just get them snug and not tight. And we'll put on the vacuum valve. Put a clamp around that. Not necessarily the easiest clamps to put on, it takes a little bit of skill. And of course, don't forget to put in the lower mounting post PRT. And now with our attachments on and our test ports isolated, we have the FPG isolated from the environment, and we can give it the necessary time to reach a new equilibrium.